The broadcast is now starting. All attendees are in listen-only mode.
Pam, we're not hearing you yet, so. Oh, wait. Okay, Pam, I unmuted you from my end, so, but it's still showing you as muted. And we can hear your, we can see your screen nice and clearly too. Pam, you're still muted, just so you know. I'm not hearing anything from your end. From my end, it shows that you're, or you are unmuted from my end. So I think you have to go to the screen and press the little green microphone.
Okay, now can you hear me?
Yeah, I can hear you clearly now.
Excellent. Let me start over then.
Okay.
I'm Pam Knox. I'm at the University of Georgia, and some of you may have seen me before at Sarika. I put my picture up there so that you would have a face to go with the voice, and I may turn on my webcam at the end. We'll just see. So what I'm going to talk about today is the climate of 2014, and then look at what we've gone through so far this winter and ahead to next growing season. And I really don't mind if you ask questions partway through. If you've got a question about a particular figure that I'm showing, that's fine with me. This looks like I'm having trouble getting my slides to progress, so that, there we go. All right, so what I'm going to talk about in the talk today, and hopefully it'll take a little more than half an hour, as I said, was 2014 as a whole, some of the highlights and lowlights of the year. I'm going to talk about this winter, and I'm going to talk about El Nino, because of course El Nino is one of the main drivers of climate in the southeast. And I'm going to talk a little bit about what's ahead for spring and summer, and whether or not it's too early to talk about next winter. And for those of you who like to create your own slide sets, I have a slide at the end of my presentation that has all the links on it. So you should be able to go into that slide and just do a screen capture or something like that. And Leslie also said she would make the links available. So the idea is that you can take this basic slide show and turn it into something that's more personal for your particular clientele or your agency. So that's what I'm going to talk about for the next 30 minutes or so. And I want to just start out by talking about the southeast average temperature. The graph that you see in front of you is the annual average temperature from 1895 to the present, and I have a little red circle there on the latest, which is 2014. The gray line that runs flat through the middle is the long-term average from 1901 to 2000. And you can see there's a lot of variation over time. In fact, when you look at that whole period from 1895 to the present, really we were just a little bit below the long-term average, very close to normal or average temperature for that time period. But if you look at the average for the last 30 years or so, which I've shown in a lighter gray line up in the top, which just goes from 1981 to the present, you can see the average for the last 30 years has been quite a bit above the long-term average, which is not surprising because we've been in this warming regime really since about the 1960s. And so compared to that, it's been one of the colder years in the last 30 years. And I think people really remember that. The year that was closest was the winter of 2009, 2010. If you may remember, that was also a really cold year. But if you have to go back quite a long ways before that to see what the to see similar cold temperatures. Of course, if you grew up in the 60s, then this is actually fairly warm compared to that time period, but a lot of us don't remember that far back. And so that is something that we have to keep in mind. The average temperature over the long haul was pretty close to what we expect, but compared to the last 30 years, it was quite a bit colder than that time period. And the map here shows the departure from that last 30-year period. You can see that for the country as a whole, and there's really quite a variation across the country. In the western part of the U.S., they're way above normal in temperatures. It's been very warm there. That's associated with the drought in California and the West Coast. So they've been under really a ridge of high pressure, and the East Coast has been under this blast, which you can trace back all the way to the Siberian continental region. Which is amazing. It has come all the way across the pole and has come down into the eastern part of the United States. And so we've been in this pocket of cold air. In the southeast, we've been maybe 1 to 2 degrees below normal, with the exception of the Florida Peninsula, which has been a little bit above the long-term average. But if you're up in the Midwest, where I grew up in Michigan and Wisconsin, they really had a brutal winter. It's been very cold. And so, we've gotten off relatively light compared to other parts of the northern parts of the country. And the real culprit for that has been this persistent area of high pressure on the west coast and low pressure on the east coast. And I sort of drew a black line here, which indicates the basic boundary between the warm air and the cold air. And so you can see that that feature has been very persistent. It's been amazing to me how persistent that's really been all the way through 2014. We don't see that pattern lasting so long most of the time. Usually it switches up, and it's very interesting to see that because it's not necessarily what we expect. In some respects, it goes back to the weather patterns we saw in the late 1970s. You remember back then, I was in college then, and we had a lot of snow in Michigan. Very warm water off the coast of California, as we have this year, and that has really locked that ridge into place. So we've had a lot of consistency from one month to another. Now, if you look at the whole global temperature pattern, this is the global temperature pattern, you see that the eastern part of the United States is actually one of the few parts of the world where we've had these cold temperatures. There's another place in sort of Eastern Europe, Western Asia that has also had cold temperatures, but most of the world is above the 30-year average. And so local perceptions of it being a really cold winter are a little bit skewed by the fact that we're stuck in this pocket of cold air, whereas most of the world is quite a bit above normal. And in fact, the predictions are that February is going to be the 6th warmest February on record for the globe as a whole. So local perceptions do vary quite a bit. If we look at the climate division rankings of temperature across the United States, here the red shows the rankings that are much above normal, and you can see in the West Coast they've set record high temperatures, which again has contributed to the drought in California. Whereas if you look at the Mississippi River Basin, has set much below average. It didn't quite break any records there, but definitely much below average for the year as a whole. The only exception in the southeast was the southern part of Florida, where they were really quite warm. So they escaped a lot of the blasts of cold air that the rest of us experienced. But generally, the southeast as a whole was a little bit cooler than average, but not hugely so compared to other parts of the country. And of course, looking at one number for the year doesn't really give you a good sense of what was going on. I just picked a climate graph here for Macon, Georgia, because it's kind of in the middle. In Macon, Georgia, you can see, let me just explain what this is, because there's a lot of stuff going on. The green lines here represent the average or the normal maximum temperature and the normal minimum temperature. So you can see that range as we go through the year, as the seasons and the sun change. And the reds represent the daily record high temperatures for each individual date. The blues represent the daily record low temperatures for each individual date. And you can see that in the key down below. And then there's this gray line that shows the actual weather values in 2014. So you can see weather doesn't really follow a normal pattern. It tends to go in these waves of highs and lows. You can see a lot of that. I put some stars here on some months that we're going to look at in just a minute. But one of the things that you can see here is that the spring and fall had a lot of waviness in the weather patterns. That's typical when we have what we call this high amplitude pattern, where we've got big troughs and big waves in the atmosphere. So we get these big swings in temperature. We broke some records or came close to breaking some records in January for lows. And January as a whole was quite a cold month. The 32-degree line here is shown in the light blue. Of course, a critical factor for agriculture in the southeast. If you look in the fall, again, we saw that really wavy pattern. One of the things that's amazing to me is that if you look in the summer, here from about mid-May until mid-September, those gray lines are really, really close to normal conditions, with a couple of exceptions, which I'll mention in just a minute. And it's actually fairly rare to see weather be that close to normal for such a long time period. So that was a very stable pattern. Did have some problems with rain in some parts of the state, which I'll get to in a minute. But it's really amazing to me to see how close the temperatures were to normal. If you remember back to mid-July and late July, there were two cold outbreaks where the temperatures really felt more like they did in October. If you look at the high temperature here in mid-July and you just follow across, that's more like the average high temperature in mid-October. So there were a few days there in July where it was really cold. And then we had another cold outbreak right at the end of the month into the beginning of October. And that made July a fairly cold month. But generally, most of the summer was very moderate, didn't have a lot of high temperatures, so didn't have to really sweat too much, at least compared to usual for the southeast. We look at some of those months that I had stored. Here's the January divisional rankings. You can see they changed the format halfway through the year. January was very cold in the east and very, very warm in the west. That pattern continued in July here on the top right and November on the bottom. That pattern of warm in the west and cold in the east really persisted throughout the entire year. And it's just really amazing to see that. You can see that here in July, actually, parts of the Mississippi River Valley set their record coldest ever Julys, and partly that was due to that cold outbreak that I showed you in the Macon temperatures. And so that was a surprise for a lot of people. Now I'm switching over to precipitation for the year. This is the same graph from the Climate at a Glance tool from the National Climatic Data Center, which shows the annual average rainfall from 1895 to 2014. Again, I've circled the 2014 on here. Compared to the long-term average, we're just a little bit above average for the long term, but you would probably consider that within the range of normal because a lot of the years are much farther away from that average line, this particular one. In fact, it's dry this year compared to last year, which was fairly wet. One of the things you notice here is that unlike temperature, the precipitation really doesn't show any trends over time. There's a lot of year-to-year variability, but there's really no trends that we see, at least in the annual average precipitation. For 2014, the year as a whole, of course, one number for the whole region doesn't really do it justice, and there was a lot of variation across the southeast. You can see that in the southeast here, even across just Georgia, the southern half of the state as a whole was fairly wet. The northern half was fairly dry, and then there was some real heavy rains that occurred around Tallahassee and so on. A lot of those did not occur, unfortunately, during the growing season, but occurred earlier in the year or later in the year where they were really less effective. You also see some dry conditions here in the southern part of Florida. That has to do with the above normal temperatures as well. They just didn't have a lot of action. But again, compared to other parts of the country, really the key here in the East Texas and on into Oklahoma, they were very dry and had problems with agriculture because of that dryness. And the Pacific Northwest, even though they were partly in a drought, did get a lot of rain, especially late in the year. Now they don't have a map that shows all the precipitation anomalies for the globe as a whole, but this shows the global precipitation anomalies starting in 1900 and going to the present. And you can see that unlike the US, there is a trend in precipitation across the globe as a whole. And Earlier in the period, it tends to be a bit drier. There's been some ups and downs, but later in the period, we tend to have more wetness. So even though we don't see trends here locally, there are trends in the global precipitation patterns. And that's not surprising because really with warmer conditions overall in the globe, the whole atmosphere is more juiced up. It's more likely to create thunderstorms or other kinds of storms that drop rainfall. And so we've seen a tremendous amount of problems with flooding in places like Malawi, where they've really had problems with that. For the U.S., looking at the divisional precipitation ranks, again, you can see some variation across the southeast. Dryness generally centered to the north in the mountainous parts of South Carolina and in the far northeast of Georgia, and then wetter conditions sort of scattered across southern Georgia, Alabama, and the northern Florida, with the wettest much above average in this climate division that covers northern Florida. But again, you're looking at the annual average, and really you want to see what happens month by month. So I went back to the Climate at a Glance tool and just looked at the month-by-month variations of precipitation. And what you see if you look at it month by month is that the first 3 months of 2014 were fairly close to normal. They were not really far separated from normal conditions. Then we hit April. April was a huge amount of precipitation for the southeast as a whole. In fact, it works out to be the third wettest ever in the period from 1895 to the present. So that caused a tremendous amount of problems for farmers that are trying to get into the field. The most recent years that have been very similar in precipitation amounts have been 1979 and 1983. So you really have to go back all the way to 1983 to find a year with similar rainfall in April. And it really caught a lot of people by surprise. They weren't able to get into the fields. It delayed a lot of planting, caused a lot of problems where people were not expecting to see that much rain, but it did happen. And I guess in retrospect, it was probably fortunate because during the summer we went into an extended period where the precipitation across the southeast was below normal. And so we didn't have a lot of rain. So the rain that we got in April kind of help build up our bank account a little bit so that we had some moisture going into the heart of the growing season. And then when we hit fall, September, and the later months in the year, rainfalls did start to pick up again. So, the total for the year was very close to normal, but you had this variation where you have 1 month like April that's huge, and then the growing season, which was fairly dry. So 1 month for the year doesn't always give you a good picture of what's going on, at least in terms of trying to, work agriculture. Probably one of the key culprits for that dry summer was the tropical season this year. You can see here's the map that shows all the tropical storms that occurred in the Atlantic this year, and there were several of them. There were 8 named storms in all, and every single one of them missed the southeast. The only thing that really hit was the first storm here, Arthur, which sort of clipped the eastern part of North Carolina and brought some rain to the area, but really not a lot. And so that was a huge problem because in the southeast we can get up to 30% of our summer rainfall from tropical systems, and if you don't have them, then you are more likely to go into a drought. And that's exactly what happened this year in parts of Georgia and Alabama in particular. Just looking at a couple of the months that I pulled out, here's the map from April that shows across the southeast there's a region that's much above normal or much above average that really extends through all of Alabama and most of Georgia and a little bit of Florida as well. You can see there's one area here right around Mobile that set their record wettest April ever. They had some tremendous rains during that time. It's interesting now that they're in the middle. They're the only place now that's in a drought. And so short-term conditions can affect longer-term conditions, but they don't necessarily have to. A couple other months, here is September, where the wetness was mostly along coastal areas of the southeast and dryness more inland. And then the flip-flop the next month in October, where the dry conditions were along the coast and the wet conditions were farther to the north and farther inland. And so there was quite a bit of variation there in terms of rainfall. Having rainfall during September and October is a sort of a mixed blessing because a lot of times farmers are trying to harvest and they need to get into the fields. They've got something like cotton or peanuts that they're trying to dry down. Not always a very useful thing to have rainfall in the fall. If we look at drought, these are some pictures from the drought monitor starting at the beginning of the year, January 7, at the peak of the drought, at least in the southeast as a whole, and then at the end of the year. So you can see we started out the year with a little bit of dryness. These yellow areas are areas that are abnormally dry, but they're not considered to be drought. And then we ended the year also with most parts of the southeast having just a little bit of abnormal dryness. Here's the drought, just a moderate drought that I mentioned near Mobile, and that has actually expanded in 2015 because they have continued to be fairly dry. The peak of the growing season, notice this is at the end of that string of months that were below normal in precipitation. There was an area across southern Georgia and extending down into Florida where we had really some severe drought occurring in just a few scattered pockets, and farmers down there, especially in southwest Georgia, were really complaining about the lack of rainfall because you really need to get at least an inch and preferably more than that every week to keep the crops happy. So they're having to do a lot of irrigation down there to make up for that water deficit. We just look at the percent of the southeast that's covered by the drought. This is a nice little feature from the drought monitor. This product started in 2000, and so the height of each of these different color bars just tells you how much of the area was covered by drought. So it goes from 2000 to the present, and the yellow or red just indicates what percent was covered by different degrees of drought, the red and the dark red especially being the worst drought. So you can see the southeast has had a tremendous amount of drought in the last 15 years or so. When I came to Georgia in 2001, we were already in the middle of this drought that really went from about 1998 to 2000, then that ended. We had a few years where it's fairly wet. Those are also years when we got quite a bit of tropical storm activity. You can remember Ivan in 2004, Katrina and Wilma in 2005, and a number of other storms. So there was a lot going on then. And then in late 2006, we started to develop a drought again in the southeast, and that became the infamous drought of 2007 to 2009, which Georgia's governor at the time had a public prayer meeting for rain, and the media were talking about Atlanta running out of water in a month, which probably wouldn't have happened, but certainly made good press. And I know here in Athens, they were under very severe water restrictions as well. And so all of those things were going on, and the drought got to be very bad right around Christmas time in 2007, and then we started to get some relief. And even though it stayed around, after that it was less intense. And of course, being out of the growing season probably helps a bit too. So then we had another year or so of drought-free conditions, or at least just a little bit of dryness. And we went into the third big drought of the last 15 years, which started in 2010 and scattered across the area. Now this drought, the 2007 to 2009 drought was really across all of the southeast, but it was especially focused north of Atlanta. So because Atlanta's a big media market, caught a lot of attention. The 2011 to 2012 to 2013 drought was a very severe drought in mid to south Georgia. In fact, it was probably worse in some places than the previous drought, but there's no big media markets there, and so they just really didn't get a whole lot of attention. And there's various political reasons why the government in Georgia especially did not want to put in water restrictions because they thought it would hurt the landscape industry. So that was a very quiet drought for most places, even though in some respects it lasted longer and it was more extreme in some locations at least than the previous drought. Then since then, 2014 here, you can see that period of abnormal dryness and then just a little bit of the area covered by drought in 2014. So right now, there's just a very small area in the southeast that still has a drought. That's mostly right around Mobile. We look at the southeast. This is the Palmer Drought Severity Index from the same graph as a whole. Again, 1895 on the left. to 2014 on the right. You can see that for the southeast as a whole, we actually didn't have a whole lot of drought. It was fairly wet. And it's also, I think it's very interesting to notice that there's this period here from about 1958 to about 1980, which climatologists call the benign period, because really during that period there was no drought in the southeast, just some really minor stuff. And since then, the amount of drought has increased. So if you look at the producers, a lot of producers, farmers are in their 50s or so. They grew up in that period where you could really get a crop in every year. And people's perceptions have changed quite a bit because lately we've gone back into this period. And through the miracles of PowerPoint, I was able to take the temperature graph that I showed earlier, compress it down, so you could kind of see how the benign period relates to the temperature. The period when we had no droughts was also the period when we were the coolest in temperatures. And of course that's a concern because as we continue to rise in temperature, at least we have more most recently, that means the likelihood that we're going to see more droughts also goes up. And it's something that farmers have to manage for. It means that there's probably going to be more irrigation needs in the future because you have to be able to get through those dry periods. And so that's something we're watching. Precipitation really didn't change that much during the period. It's just that the heat and the evaporation and evapotranspiration caused a lot more stress on the plants when the temperatures are warm. So let's look ahead now and look at 2015 so far. This is the year-to-date departure from normal for precipitation. This is taken from radar estimates, and you can see across the southeast there's a broad area of fairly dry conditions, not tremendously dry. As I said, the drought that is existing right now, it tends to be near Mobile and in southern part of Alabama. And so those areas have been drier, but generally it hasn't been too bad. Of course, you know, it's only 2 months into the year, so obviously we have a long ways to go. We look at departure from normal temperature. The big map here shows the southeast, and generally we're covered, I'd say most of it is probably in this -2 to -4 range in temperature. It's been cool across most of it, again with the exception of southern Florida, which is in dry and warm conditions. But compared to the rest of the country in the small inset graph, you can see that to the north they're a lot colder, and again to the west much warmer than we are. So even though we've been relatively cool, certainly have not seen anywhere near the same extremes of departure from normal as other parts of the country have. Of course, El Nino has always been important. Last March, already they were talking about the development of an El Nino, and it kind of teased us all year. El Nino occurs when you have warm ocean waters off the coast of Peru and Ecuador, and that can shift the atmospheric circulation really all around the globe, and definitely in ways that affect us here in the southeast. This is the latest sea surface temperature departure from long-term average. Some of the things that you can see in this are, first of all, the tremendous amount of warming off the west coast of the United States. Those unusually warm ocean temperatures really have been the driving force that's kept that high amplitude pattern with the high pressure and the ridge on the west coast and the low pressure on the east coast. That's really kind of locked it in place. So as long as those temperatures continue to be much warmer than average, it's probably going to keep that circulation tide pretty much looking the way it does now. The other thing to notice is that there is this pool of unusually warm water, not really off the coast of Peru and Ecuador at this point. It's farther to the west in the Pacific Ocean, but it is a sign that the El Nino conditions are kind of there, and we've really seen that this year in some of the anomalies we've seen, particularly in the lack of tropical storms that have hit the southeast. Usually when you have an El Nino, the tropical storms in the eastern Pacific are enhanced because you've got all this warm water, and the tropical storms in the Atlantic tend to be reduced because you've got a strong jet stream that keeps the storms from developing. So there definitely have been some signs that El Nino-like conditions were present. They just weren't present at quite the strength for us to officially declare an El Nino. And in fact, we're still considered to be in neutral conditions, although there's some debate about whether or not they're gonna call it an El Nino. Here's the sea surface temperature anomalies. across 4 different regions. I put the map up here. Nino 4 is the one that's farthest west, so that's where that big pool of warm water is right now. And then there's Nino 1 is right off the coast. You can see that's relatively cool. That's the bottom one here. Nino 3 and Nino 3.4 is sort of in the middle, show consistently above normal temperatures, but they haven't quite stayed above the 0.5 degrees, which is the threshold for an El Nino to be called, for long enough for them to call an official El Nino. And so that's kind of the situation we're in. We've had some kind of El Nino-like patterns, but not anything very strong. This shows the Nino 3.4 sea surface temperature anomalies over time. This goes back to 1982. There was a strong El Nino at that point, and then we've gone through this period. It tends to oscillate every 3 to 5 years or so, not on a regular pattern, as you can see, but what they call quasi-periodic. So there's definitely some oscillation back and forth on a fairly regular basis, but it's a little hard to predict. Right now, we're here on the very far right-hand side of the graph, so you can see we're in this warm period, but we haven't really been in it long enough for it to be officially declared an El Nino. I believe it takes 4 months of continuous temperatures above that half-degree threshold for it to be declared an El Nino, and we haven't really quite gotten there yet. But there's been these long periods also where we've had below normal temperatures, which are the La Nina periods. And I'll be glad to talk more about El Nino and La Nina if you want. I talk about it a lot in my presentation, so I figure most people probably know what it is, but I'm happy to answer questions about that if you've got them at the end of the presentation. The forecast for El Nino, this is from the Columbia Erie Group. You can see the website down there on the bottom. Shows that right now the highest predictions are for neutral conditions, but that they think, based on their predictions, that El Nino may actually make an occurrence by this summer. You see the highest predicted period is June, July, August, so that's the summer period. Now, unfortunately, in the summer, there's not a lot of strong signals as to what El Nino effect is going to have, but if we do have an El Nino, that would tend to keep the tropics not very active as far as the southeast is concerned, so that could mean some dry conditions during the summer, which of course is a cause for concern. If that happens and we get an El Nino, it's probably going to be a fairly weak one, and the chances for that will continue over time. If you look at the plume of forecasts, these are a bunch of different forecasts. You can see there's a really big variety of different models. The dynamic models use model physics and realistic conditions to try to figure out what's going to happen with the ocean atmosphere system. The statistical models say, well, what's happened in the past, and for the number of years that had these conditions that look the same, what can we expect to see? So you can see the statistical models are pretty much pulling us all back towards normal conditions, where the dynamical models are saying, no, we think El Nino is going to develop. Really, the key thing that we haven't seen this past year is that even though the ocean temperatures have been warm, the winds above the ocean have not really linked up and given that ocean a push to push it over into El Nino. So that's kind of the key question. I think at this point I would probably say if we go into an El Nino, it's probably going to be a fairly weak one, and it's probably not going to last a real long time. So the official El Nino forecast from NOAA is that they say there's an approximately 50 to 60% chance of El Nino within the late northern hemisphere winter and early spring, and then probably neutral favored after that. So there's not a strong forecast push there one way or the other, but a slight chance towards El Nino. We look ahead in time. This is based on the Climate Prediction Center's 3-month predictions for what's going to happen. We see that for the next 3 months, this is March through May, EC means equal chances, which means that we really don't have a strong signal. The West Coast is expected to continue to be warm, whereas in Texas is expected to be cold, but there's not really a strong signal for most of the Southeast. For precipitation here on the lower right, some signal that we may see some enhanced wet conditions, especially down in South Florida, which would be great because it's been fairly dry there. We look for the summer period, June through August. There's a prediction that most of the Southeast is going to be above normal in temperature. That's based on mostly on trends that we've seen over the last few years, where summers have been fairly warm. No predictions on what's going to happen with rainfall because of the uncertainty of El Nino, and just really having a hard time predicting small summer thunderstorms anyway. For the fall, predictions are equal chances for the southeast for both temperature and precipitation. There's not really a good feel for what's likely to be happening there. Now, if you want to keep track of this, there's a couple of really good places to look. One, of course, is AgroClimate. And here's just a screen capture of the main website showing the tool section where there's monitoring. You can look at maps like I've showed today, which show you departures from normal. Climatology will show you what's expected to happen, or you can look at individual weather stations. You can break a lot of this information down by El Nino phase. So if you think we're going to be in an El Nino, you can see the impact of just El Nino on crop yields or freeze probabilities or the amount of rainfall, things like that. So that's a great source. The tools are an excellent place to start for that. Also want to put a plug in here for my own website, which is new, and we're just developing, georgiaclimate.org. Has a lot of the same kind of information. You can see it's got AgroClimate listed here and also the Georgia Automated Environmental Monitoring Network. So we're going to be putting more and more stuff on. We'll probably put a link to this presentation on there eventually. Another great source of looking for it. Now, I said at the beginning of the talk I would say something about next winter. Really the key issue is going to be what happens with El Nino, and it's not going to be a strong signal probably for at least a few months. The Climate Prediction Center is predicting that there is at least a chance of below normal precipitation in southern Georgia and Alabama and into northern Florida. I'd say at this point that's pretty iffy, but it'll be interesting to see what happens. If we have a dry winter, that's often a sign that we could go into a drought the next year, but again, not something that we can really bank on at this point. So in summary, 2014 was slightly cooler and wetter than the long-term average. So far, 2015 I think looks pretty similar because we've just had that locked pattern, and that those warm ocean temperatures seem to be holding that in place. So I don't see any big changes in the near future, at least. It's been wet enough that I think the growing season should start with plenty of soil moisture. We'll see what happens if it's above normal in temperature. That may be an issue later in the season. With this high amplitude pattern that we've had this year, there is some chance that we're going to have a late frost after a warm spell because we get these big swings. That's already been a problem this year for some of the blueberry growers in Florida and South Georgia. So that's something that we're going to keep in mind. I know people have already asked me, is it time to start planting gardens? And I say, no, it's too early for that, especially in northern parts of the southeast. And then finally, El Nino has a good chance of returning this year, but it's probably going to be weak. So it'll have limited effects on the climate here in the southeast. I promised you at the beginning of the talk that I'd give you a page that has all the links I used to create the graphics in this talk. So I'm going to leave it on here for just a minute and encourage you to think about questions. I don't have my questions page sticking out, so I can't see if anybody has written any so far. All right, looks like there's just a few comments, but we'll open it up for questions in just a minute.
And everyone should be unmuted, so feel free to unmute yourself and speak up and ask the question. You don't have to write it.
All right, and I'm going to just go ahead to the last, I think the last slide here, see if it behaves. There we go. My contact information, I appreciate your coming to the webinar today. This picture was actually taken in 2009 when we did get snow. This year we just got cold rain and I saw about 5 flakes. So my contact information is here, my phone number, the website, georgiaclimate.org, and I've got a blog also where I talk about a lot of this information, blog.extension.uga.edu/climate. And
Okay, I'm going through and unmuting everybody so that they can talk, so there won't be any issues.
Hi, Pam. This is Shelby.
anybody? Hey, Shelby.
Thanks for the presentation. I have a question about the 32-degree threshold for agriculture. Where does that come from and what does it mean?
Well, 32 degrees is the freezing temperature of water. And
Right.
so when you go below that, you have cellular damage to a lot of plants. Now, 32 degrees is not appropriate for all plants. Some plants can take 32 degrees just fine. And I think there's some plants like celery, which can go down quite a ways below that. So for different crops, you have different um, temperature thresholds. 32 degrees is just sort of the general one that's used over time. But I think on agroclimate, you can actually go in for some of the different crops and set your own temperature threshold depending on what crop you're using. And so that's just generally because of the freezing point of water.
Okay. Quick point here: if you aren't asking a question, please mute yourself. But I unmuted everybody so that there'll be no issues about them having audio. But if you're not talking, go ahead and re-mute yourself. If you would like to talk, go for it.
Any more questions or comments? I guess I blew everybody away.
Well, it was an amazing presentation.
If you got other questions, of course, you can always contact me later and ask. If you have noticed anything unusual with impacts on agriculture this year, I'd love to hear them.
Venkat asks, could you comment on the growing degree days?
Yeah, the number of growing degree days. We know that chill hours this year for fruit trees like peaches and blueberries has been good because it's been so cold. Growing degree days, the method that you use to calculate growing degree days varies depending on what crop you're looking at, and agroclimate has various ways of doing that. Obviously, not a whole lot's growing right now except in the Florida Peninsula, but growing degree days for last year, 2014, were a little bit below the long-term average because it was a little bit cooler, at least the 30-year average. But I don't recall that there was any early or late frost, so I think the growing season was fairly close to normal. A couple of close calls, but I have not looked specifically at growing degree day maps because they're a little hard to come by.
Does that answer your question, Venkat? Okay. Hao Chen asks, any thoughts on causes of record snowfall in Boston?
Yeah, the amount of snow that they've got in Boston this year has just been incredible. Part of it is they've got this really cold air that's coming in from Siberia. The other thing is that the ocean temperatures off the East Coast are also above normal. So when you got this cold air that's meeting this really warm and wet condition, that just the atmosphere just really soaks up the water and creates a much higher water content. And so I think it's that combination of the really cold temperatures and associated with the warm water that's really feeding into those East Coast storms this year. But I tell you, I am glad that I am not living in that part of the country.
Okay. Are there any more questions? Maggie's mic is not working, Maggie Clifford. She said, thanks so much for the talk, Pam. Could you speak for a moment about these high amplitude patterns? I know that it has to do with high and low pressure, but can you explain this phenomenon a bit more?
Sure. Well, the high amplitude pattern, the atmosphere has movement of air at various levels in the atmosphere, and generally it moves in the northern hemisphere from west to east. Some years it's mostly a straight west to east flow. So other years you've got these big loops in the flow, so that it's like a meandering stream. You've got big loops going one way or the other way. And this is one of those years when we have more flow that's either coming from the north, if you're in the eastern part of the United States, or from the south, if you're in the western part of the United States. And those are linked to high and low pressure regions. It's the mathematical circulation around low pressure and the balance of forces there. So some years it's very east to or very west to east flow, and you don't get a lot of variation from one season to the other or from one day to the other. And then there's these years like this year where we have periods where you've got a lot of flow from the north in one area, a lot of flow from the south in the other. And if those waves shift just a little bit, you can actually get big swings in temperature where you might have really cold temperatures one day and then a couple days later the wind shifts to the south and you have a lot of flow. The thing that's been interesting this year is how constant that's been, but there have been some signs that may be shifting. Now, there's been some recent research that indicates that this may be linked to the changes in sea ice in the Arctic. There's a scientist at Rutgers who's been looking at that. Unfortunately, her research only looks at the 1990s to the present, so it didn't capture a lot of the years in the 1970s where we had a lot of these swings. I mentioned some of those before as well. And so it's not entirely clear whether this is linked to that lack of sea ice and having more water available at the surface, or if it's just a longer term pattern that's repeating and that we haven't seen in a while.
Sam Ingram asks, Maggie says thank you, and Sam Ingram asks, is it too early to plant corn in South Georgia?
You know, I know that some people are planting it now, especially sweet corn, because the market is just really worth it. Generally, you don't want to plant corn until the surface temperature is probably at 55 or above. And parts of South Georgia have been flirting with that now, but you know, they get above 55 for a day or two, and then we get another cold blast and it goes back below. So I think you could plant it, but I think that seed's just going to sit there and not do a whole lot to start with, and might bring up some problems with germination and so on. So I think you could do it, especially if you're trying to get ahead of the market. I'm not sure how well it's going to do yet at this point because it really isn't quite warm enough to take off.
Well, Mark Shirley asks, early in the presentation you had a slide that showed the global temp average that showed North America was cooler, but other areas around the world were warmer. What time frame was that, 50 years or 100 years?
I believe that was just the last year, 2014.
Okay.
And so, yeah, it's compared to an average. The average time period for that graph was 1981 to 2010. So it was a 30-year average, and comparing that 30-year average. So you know, you have to keep in mind that longer time periods than that might have a different average period. So this was warm compared to the last 30 years. Probably even warmer if you compare it to the longer term.
Cool. Okay, does anyone else have any more questions? Okay, I think, well, thanks so much, Pam. This was a great talk, and we appreciate it. Thank you, everybody, for joining.
I'm looking forward to hearing more from other folks for other webinars in the future.
Yeah, and we will have, we're going to have another, Paul Vincelli from University of Kentucky is going to speak to this webinar series on April 24th. But we have openings if anyone wants to propose a webinar topic, either to speak themselves, or if you have a topic in mind that you'd like to be covered, please let us know. We'd be happy to find someone to do that. It could be a panel, or if you wanted to speak briefly, you know, for 15 minutes and share it with someone else, that's fantastic. I think we're really open, so any topics, anything. But that's about it. Again, thanks again, Pam, and we've enjoyed it, and everyone have a great Friday.
Thank you.